All right, guys, you just finished your investigation of similar triangles on Geogebra and which shortcuts will and will not work for similarity. So you went through side, 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 tested it out, angle, side, angle, 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 side, side, angle, side, 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 angle, and then ended with angle, angle, angle. And what you should have found out is that every single one of these shortcuts works except for one. And I know that your answers may not have come out 100% perfect. Like, for example, on this angle side test, I couldn't get this side length over here to be perfectly 14. And so that would have messed up my ratios just a little bit. But again, aside from those little things, you should have realized that everything worked for similarity except for side side angle. And the best way to show that is to take this point E, and first of all, remember that this dashed line is here because I haven't predetermined how long this side has to be. Okay, that's kind of up in the air, and there's different options for it. And so what happens is you can take this point E, you can make a triangle right there if you want to. So that's one pair of similar triangles. But I can also keep swinging this around and make a new triangle there. And then these, you can tell just by looking, I know we didn't measure, but these two triangles are definitely not similar. So side side angle is the only one of these shortcuts that isn't going to work because you don't know which one of these two triangles you're going to get out of it. And the other thing is that these two here, so angle side angle and angle angle side, were really like kind of unnecessary, kind of pointless, because what we realized at the very end of it was that if I just have angles and that's it, okay, even just two angles, if that's all I have, that's enough to guarantee similarity. So we don't even need a side length at all right here. Okay, so we're going to write that up in these notes. So just first a refresher on the definition of similar polygons. So when we're just speaking informally, we say that they're the same shape and just different sizes. But technically what that means is that all of the angles are congruent and the corresponding side lengths are proportional. And so again, when it comes to triangles, there are certain shortcuts we can use to show similarity. And these shortcuts don't work for other polygons. Okay, I realized that we didn't mess with any like quadrilaterals or anything today, but these shortcuts aren't going to work for other shapes, just triangles. And so we can really narrow it down from this long list of options. We can really narrow it down to just three that we need to worry about. So the first one is the side, side, side similarity shortcut. And that says that two triangles are automatically similar if all three pairs of corresponding side lengths are proportional, and we don't need to know the angles. So when we wrote up our notes for the congruent shortcuts, we labeled one picture that had like tick marks on the side lengths and arcs in the angles, and then we labeled one more picture that had more like concrete measurements. We'll do the same kind of thing in this note guide, except we can't show proportional sides with like a symbol. There's not a symbol for that. And we don't want the same sides, so we can't use tick marks. So what we'll just say is that this first triangle has side lengths that are A, B, and C. Okay, it looks scalene, so it looks like those three measurements would be different. And so if another triangle has side lengths proportional to that, it's going to guarantee itself being similar to the first one. And you should know by now that the way that we guarantee proportional sides is like we have to multiply these original side lengths, okay, or divide if we were getting smaller. And so to show, I don't know, that we're going to double the side lengths, we would just say, okay, this is 2 times whatever A was, and this is 2 times whatever B was, and 2 times whatever C was. Okay, again, there's no symbol for proportional sides. We can't just use tick marks because we don't necessarily want them to be the same. Okay, when it comes to actual like true measurements, it's obviously much easier to see. Let's say, for example, this triangle is a 3, 4, 5 triangle, so it has those side lengths. And let's say maybe we wanted to triple those side lengths instead of double them. Okay, well, this side that corresponds to the 3 then would become 9, and 12 here, and 15 here. And so again, the side, side, side similarity shortcut. And by the way, make sure, I guess we should add this, an abbreviation. The side, side, side similarity shortcut says that if two triangles have proportional side lengths, they're guaranteed to be similar, and we don't need to mess with the angles. Okay. Oops. Okay, there we go. Next up was the angle-angle similarity shortcut. And again, we don't need angle, side, angle, or angle, angle, side. When it comes to these two, the side is really pretty pointless because what we realized down here at the very end was that just 2 of the angles was enough. Okay? So the angle-angle similarity shortcut tells us that 2 triangles are automatically similar if 2 pairs of corresponding angles are congruent. Okay, we don't need to know the last angle measure because no matter what, that third angle is going to end up being the same, and we don't need to know any of the side lengths. So to show that with some, I kind of switched it up, I guess, here, to show it with like some concrete measurements. Let's say this bigger triangle has an angle of 120 degrees here and 40 degrees up here in the top left. So if this smaller triangle has those same 2 angle measures, okay, we automatically know that those triangles are going to be similar. Again, this third angle, even though it's not labeled on the picture, it's forced to be the same since the total has to be 180. And then again, we didn't need to know any of the side lengths. Okay, in terms of like just a general picture, so we would need 2 pairs of corresponding angles that are congruent. So there's 1 pair there, and then maybe like a second pair down here. Just those 2 pairs of congruent angles of, corresponding angles that are congruent is enough to guarantee similarity. Okay, and then last but not least, okay, and I realize that this note guide goes out of order a little bit from the way you did it on the computer, but last one we're going to write up is side angle side similarity shortcut, so SAS for similarity. Says that 2 triangles are automatically similar if 2 pairs of corresponding sides are proportional and the angles in between those sides are congruent. Okay, we don't need to know the third side length or the other angle measures. Okay, so again, let's start out with our 2 side lengths, and we'll call them A and B right here, and then that angle in between them. And so if in this larger triangle, these 2 side lengths are proportional, so let's just say again that we maybe doubled them. So this is 2 times what A was, and this is 2 times what B was. Okay, but they have the same angle. That's enough to guarantee that these 2 triangles are going to be similar. Okay, in terms of maybe some concrete measurements, or at least partially concrete, let's say this side length is 7, this side length is 10, and there's an angle right here. And so in the bigger triangle, again, maybe we doubled it. This side length is 14, this side length is 20, and then it still has that same angle. Okay, that side angle side setup, but this time with proportional sides, so 2 times bigger, will guarantee our similarity. All right, down below on example 1, you'll need to use your protractor for this because you do need to measure it. I didn't measure, obviously, with like a ruler or anything, but the directions were to show that, to draw an example showing that just because 2 quadrilaterals have, and by the way, I think your copy is correct, this is supposed to say proportional side lengths, okay, not same, proportional side lengths, doesn't make them similar. So what I've done here is, even though I can't measure with like a ruler or anything, I took these side lengths in this first quadrilateral, I physically doubled them in size, but yet I was able to change these angles. And so even though our side lengths are proportional, these two quadrilaterals are not similar because of the change in the angles. So again, these shortcuts, I'll say it probably 100 times before we're done with the unit, these shortcuts only work for the triangles. All right, so here at the end, you can choose to pause the video and try these on your own, or you can just watch and listen and fill it in. That's either way is fine with me. But I want to know, are these polygons similar, congruent, neither, or is there not enough information? So we're not just talking similarity in these 6 examples, but both similarity and congruence. So we'll have to tie in the stuff from last time also. All right, so what we have going on here in the first picture, you can see that all of these side lengths have been doubled. So 2.5 is now 5, 6.5 is now 13, and then 6 is now 12. This tells us that the triangles have to be similar by side, side, side. So that was the first shortcut that we wrote up today. Okay, moving on to part B. We don't have like true concrete measurements for these angles here in the bottom right corners, but we know that these triangles have a 90, and then this second pair of angles is also the same. And so this would make our two triangles similar by angle, angle. Okay. All right. Moving on down to part C. It looks like we have a side angle side setup going on here with these two triangles. However, if you look closely, this 20 corresponds to that 10, and this 15 corresponds to that 5. So even though we have a side angle side setup, these triangles are not similar, and they're obviously not congruent either. But they're not similar because these two side lengths doubled, but then the other ones tripled. Okay, and so if we really truly drew it out to scale, we would be able to see it clearly in person that these two triangles really would not have the same shape. So we'll say neither, okay, they're not similar or congruent, and our explanation there is that the sides aren't proportional. Okay. All right, so on part D, we know the side lengths of both of these quadrilaterals, and it looks like all of our side lengths have been tripled. So we might be tempted to say that these quadrilaterals are similar. However, we don't know what these angles are. They sure look like they're probably 90 degrees, but we need to stop here and say that there's not enough information because we need to know the angles to be for sure. Okay, need to know the angles. All right, on part E, we can see that we have a pair of corresponding sides here that are congruent. We have a pair of corresponding angles that are congruent, and then a second pair of corresponding sides that are congruent. And this is set up in a side angle side type of way. And so we can say that these two triangles are congruent by side angle side. Okay, and last but not least, here on part F, we have a situation, or at least a picture, I guess, that's pretty similar to what we had in part C, where we have like a side angle side type of setup in both triangles. And if we look at the side lengths, 7 went to 21, so that tripled, and 5 went to 15, so that also tripled. So this time, unlike before, back on part C, this time we can say that these are similar by side angle side because the sides actually are proportional this time. Okay, so that's it for the notes. On the homework, just FYI, the first part of it will be just similarity and similarity only, since that's what we're trying to practice today. But then when you get to the second half of it, or get to the bottom side of the back, it will be a mixture of both congruence and similarity.